Welcome back. We're on to our last technical big idea in these problems. This is going to be broken down into two videos, and the big idea is about parallel and perpendicular lines. Okay? Pretty simple concepts to go through, but we want to kind of make sure we understand them well. All right. Are any of these lines parallel? Well, it definitely looks like lines K and N are parallel. And it looks like M and Q are parallel. But how do we know? Well, we don't. We need to actually find out if they're parallel. And in order to do that, we're going to find out the slopes of those lines. So take a second to draw some slope triangles. I'm going to make this a little bit bigger and in a slightly different color. Okay. Boom, boom. There's my slope triangle for that one. Here's my slope triangle for this one. M and Q. I don't know if those are parallel, but I do know that their slope triangles are just a little bit different. Notice how this one goes up 1, this one goes up 2. This one goes over 5, and this one goes over 3. So if I were to think about the slope of line N, M of line N is equal to 1/3, rise over run. But the slope of line Q is equal to 2/5. Their slopes are not the same, okay? Now, because their slopes are not the same, this one is just a tiny bit steeper. See, every 3 squares over, this goes up 1. But every 6 squares over, this is going to go up a little bit more than double that, a little bit more than 2. So this line's a little bit steeper. Tiny bit, so you don't see it on this graph, but at some point, they will intersect. Those two lines will intersect. So they are not parallel. Okay? And let's take a look at this one. Or at these two. Different color here so we can compare them. And let me pick pink actually. All right, we're going to pick a point on the line. There you go. Goes down 4 and it goes over 3. Well, it's a good equation for our slope. This one starts here, goes down to here. This one goes down 4. Is that 4? 1, 2, 3, 4. And it goes over 3. Wait a second. If I look super close, the intersection's right here, but the line's here. So that's actually not a good place for it. I want to make sure it actually goes to the right spot. So I'm going to go down 5 and over 4. Okay, look at those two slopes. The slope of line K is equal to, well, it goes down 5, but then I put a negative on it, over, and how much does it go across? 4, -5/4. What about the slope of line Q? The slope of line Q goes down 4, so that's a 4 with a negative because it's going down, and it goes over 3. Those slopes are not the same. So if we take a look at our different slopes, I'm going to write the first two in blue. The slope of N is equal to 1/3. The slope of Q is equal to 2/5, not 5/2. 2/5. 2/5. And then the slope of line K is equal to -5/4. And the slope of line N is equal to -4/3. Now, the slopes are not the same. Because the slopes are not the same, those lines cannot be parallel. And that is our simple parallel lines theorem. Okay? If the slopes are not equal, then the lines are not parallel. Now, this leads to a very simple axiom I want you guys to practice. You can even state it right now, okay? This is a very important theorem for us to use. As a matter of fact, for the only time I think I've ever done it. I'm going to change my font. And this is a big statement. Parallel lines have the same slope. Okay? They're going to go in the same direction, so they've got to have the same slope. They don't just have to look like they've got the same slope. They actually have to have the same slope. Okay? That is a big deal. Make sure you remember that. All right. With that statement taken care of, parallel lines having the same slope, what about perpendicular lines? What kind of slopes do they have? Take a look at lines J and K. Are those lines perpendicular? We don't know yet, but let's take a look at their slopes. First slope goes down 1 and goes over 4. That's pretty interesting. So the slope of this, of line J, is equal to -1/4. Pretty useful. All right, what about the slope of line K? All right, let's go ahead and start here, end here. Over 1 and up 4. The slope of line K is equal to 4/1. Now, it's pretty important that we write both of those slopes down that way because it makes it easy to compare them. 4/1. If I just wrote the number 4, it wouldn't be wrong, but it would just be a little bit annoying to compare them. M of J is equal to -1/4. Now, you might notice something about those two slopes. First, the two slopes have the same numbers. That's pretty nice. Secondly, the slopes look like they flipped. The 4 was on top, now it's on bottom. The 1 was on top, now it's on bottom. Okay, so they look like they flipped. And then finally, one's positive, one's negative. Well, that's pretty interesting. That leads us to our simple statement about parallel or perpendicular lines. And we're going to write it down right now. Okay, perpendicular lines have opposite reciprocal slopes. Why do I always spell reciprocal wrong? Anyways, opposite reciprocal slopes. Now, for this statement, I definitely recommend you put a few spaces after opposite because we want to understand what that means. And then make sure you got a few spaces after reciprocal. Most students don't know what those two statements mean, so let's go ahead and put something with them. Opposite simply means negative, okay? So if you're thinking about opposite, look for one negative and one positive. Reciprocal means flipped fractions, okay? Okay, that's a simple way to take a look at it and see. If our two lines are perpendicular, their slopes will be opposites. One will be positive, the other will be negative, and their slopes will be reciprocals. Those are going to be flipped fractions. All right, and if we take a look, that's what these are. So they are perpendicular. Lines M and K are perpendicular. Go ahead and test that out here. Make slope triangles, find out the slopes, and see if our lines are perpendicular. Now, in order to do that, I want you to actually write down a statement. Remember, our big idea E is not in these problems specifically. It's throughout your reasons. So this would be a statement that I would write with lines J and K. Okay? So I would say, I'd actually not write it with text. I'd write it with pencil. Delete. No, not duplicate. Delete. Delete. Okay, I'm going to write it with a pencil. Sorry, I was thinking I would write it out like that. I'd put lines J is perpendicular, and that's our perpendicular symbol. Upside down T. Line J is perpendicular to K. And how do I know that? Because the slopes are opposite reciprocals. There we go. All right, I want you to check the slopes for these, determine if they're parallel lines. Okay, go on to this next page and think about different transformations. We did this in class pretty extensively. It was really useful for us to ultimately come to this conclusion. Okay, and this is the best way to write the equation of a line, and almost always the best way to write the equation of any type of function. So here we have y equals m, that's our slope, times x minus h plus k. Now, if I were to add a square to this, this would be vertex form of a quadratic equation, okay? If I were to add cube to that, that would be a cubic equation. If I were to get rid of the m and put log, that'd be a logarithm, which you won't learn about till at least next year. If I instead put an e to the power of this x minus h, that's going to be a, what is it called, an exponential function. Okay, this form is used all over the place. It's good for you to recognize it now and to use it. And it's a pretty simple concept. All you have to do is know two things about our line. M is the slope. And h is the x-coordinate of the point. K is the y-coordinate. So all you need to do to graph a line is to use the point and the slope. All right, let's actually apply that here, and then you're going to practice it on the last two problems in the packet. So what's the equation of a line through P that's parallel to line L? So I'm going to come over here. I'm going to look at line L. That's this line. I want a line that's parallel to it. Well, parallel lines have the same slope. So I'm going to look at the equation of line L, and I'm going to take a specific look at the slope. 1/2. Okay, so I got a slope of 1/2, and then I have a point that it goes through. So I'm going to write down what that slope is, and let's do it in blue. The slope is equal to 1/2. And now I've got the equation of my line, because I've got a point and a slope. Let me go ahead and write that down right over here. The slope is equal to 1/2 because it's a parallel line. And the point is the point 4, 1. So I'm just going to go ahead and write it in this form. Notice it's the slope. I put that there, then I put x minus, and then I put my x-coordinate, then my y-coordinate. Real simple. Just kind of bring it down. Y is equal to m times x minus h plus k. All right. Looks like that. I'm actually going to change the color of this so you guys can really see a difference here. All right, so there's our equation. I'm going to replace the slope with 1/2 because we know it's going to be 1/2. I'm going to replace h with 4 because we know that the x-coordinate is 4. Then I'm going to replace k with 1 because I know the y-coordinate is 1. That's my equation. Parallel line. Boom. There we go. So if I wanted to draw that parallel line, it would look just like this. All right. What about the second part, the equation of a line that's perpendicular? Well, a perpendicular line is going to have an opposite reciprocal slope. So let me go ahead and write out the slope of our line. The slope is 1/2. It's from right there. So what's the slope of our perpendicular line going to be? Well, it's a reciprocal, so it's going to be flipped 2/1. And since the other one is positive, this one's going to be negative. Opposite reciprocal slopes. There we go. So we know our slope, and it's going to go through point P. So I'm going to write down the coordinates of the point, 4, 1. Let's go ahead and write down the equation. Y is equal to m x minus h plus k. And I'm going to replace them piece by piece. M gets replaced with -2/1. Oh, let me change that color to green. -2/1. H gets replaced with 4. And k gets replaced with 1, because that's our y-coordinate. That's our equation. Notice that I did not use any of the rest of my original equation. None of that mattered. The only thing that mattered was the slope and the point that my line had to go through. Okay, one last thing to do is just to draw this. It goes down like this, and there's our line. Boom. Perpendicular to the original line. All right, I want you to go ahead and you don't have a visual this time. You've got the equation of a line and a point. Go ahead and write the equation of a parallel and perpendicular line using the best form ever, point-slope form, okay? All right, go ahead and write it down and see if you can answer both of those questions. You should be pretty well set on this big idea.